Hi, my name is Ashraf and I will explain on the project Solar Power Production Forecasting using Random Forest Algorithm. Let's talk about the background of this study. So, renewable energy on the rise in Malaysia, especially solar energy. In 2025, Malaysian government planned to increase the share of renewable energy in its installed capacity to 31%. How to achieve this? There are going to be more solar farms going to be built. So the forecast can help to minimize uncertainty of electricity generated from photovoltaic cells. So let's talk about forecast. In the energy sector, a good energy forecast is important for system operation and planning and to ensure grid stability. So the application for this forecast will be applied on energy sector and forecast solar power production. So what are the issues here? First, Tenaga Nasional Berhad, which is an entity that governs electricity distribution, requests to send three types of solar forecasting for large solar farm. So this is to ensure the grid balancing, which is to ensure the electricity consumption match electricity production at any moment. So for this project, the aim is to forecast 7 days ahead solar power production at a solar farm, and then this is to ensure that the national grid is balanced. The dataset is taken from two different sources. First is the Solcast company. Solcast company is a company that specializes in solar power forecasting and data services. The company provides historical weather data at any given location. These are the attributes taken from the Solcast company, which is solar irradiance, cloud opacity, air temperature, dew point, humidity, wind speed, wind direction, zenith, pressure, and daytime. And for the second dataset, is taken from UiTM Dungun Solar Farm, which is solar power generation. Both of these dataset from Solcast company and UiTM is being integrated into single dataset. The dataset is collected from 31st December 2020 until 8 January 2023, which is the time span of 2 years and 10 days. The total instances are 17,783. Let's talk about the approach or the methods used to build a random forest algorithm. So at the splitting node, I use variance reduction calculation to split at each node. So this is the formula for variance reduction written in Python, which is the difference of the variance on the parent and its children. So the variance is a statistical measure that quantifies the dispersion of a set of data points around their mean. So this is the user interface for the user to use this system, which is named Solar Power Production Forecasting System. First, user need to input the CSV file, which is the data on the weather to predict the solar power production. So the output will be the solar power production forecasting. After the user enter the CSV file, two output will be generated. First is the table, which is on the left side of the table is the weather data that user input in the CSV file, and on the right side is the prediction made for this system, which is the solar power production. At the bottom, there's a line graph, which is a representation of solar power production for 7 days. These are the results and findings for this project. First, I made a correlation matrix to see the connection or the correlation between the attributes. On the right side, I rank the attributes based on the correlation matrix. The highest correlation is the solar irradiance, and then air temperature, zenith, humidity, cloud opacity. At the four bottom there, wind speed, wind direction, dew point, and pressure, I neglect in the random forest algorithm because it has too low correlation between the output. This is the test result after doing some of the configuration, the random forest. First, testing on the split ratio test, which is I test three different split: 70-30%, 80-20%, and 90-10%. As you can see, the highest R-squared value is at the 90-10%. And then I test the hyperparameter of the random forest, which is the tree depth test. I test on three different tree depth: 2, 4, and 6. The highest R-squared value, which is the best model, is at number of tree depth of 4. This is the next test on the hyperparameter of random forest, which is the number of tree tests. I test 500 different number of trees, and as you can see, the higher the number of trees, the higher the R-squared value, which means the better the model. However, as you can see, reaching a certain nodes, the R-squared value became linear, which means there's not much improvement. So as you can see here, the number of trees need to be set high, but we need to know the threshold at where the R-squared value became linear. After several tests on the configuration of random forest, this is the best configuration. First, the number of trees is set to 11, and then the maximum tree depth is set to 4, and lastly, the percentage split is 90-10%. As you can see, the result at the bottom, the evaluation are R-squared value, mean squared error, mean absolute percentage error, and lastly, mean absolute error.